A hovercraft, also known as an air cushion vehicle or ACV, is a craft capable of traveling over land, water, mud or ice and other surfaces. Hovercraft are hybrid vessels operated by a pilot as an aircraft rather than a captain as a marine vessel. Hovercraft use blowers to produce a large volume of air below the hull that is slightly above atmospheric pressure. The pressure difference between the higher pressure air below the hull and lower pressure ambient air above it produces lift, which causes the hull to float above the running surface. For stability reasons, the air is typically blown through slots or holes around the outside of a disc or oval-shaped platform, giving most hovercraft a characteristic rounded rectangle shape. Typically this cushion is contained within a flexible skirt, which allows the vehicle to travel over small obstructions without damage. The first practical design for hovercraft derived from a British invention in the 1950s to 1960s. They are now used throughout the world as specialized transports in disaster relief, Coast Guard, military and survey applications as well as for sport or passenger service. Very large versions have been used to transport hundreds of people and vehicles across the English Channel, whilst others have military applications used to transport tanks, soldiers and large equipment in hostile environments and terrain. Although now a generic term for the type of craft, the name hovercraft itself was a trademark owned by Saunders Roe, then Westland, hence other manufacturers' use of alternative names to describe the vehicles. History, early efforts. There have been many attempts to understand the principles of high air pressure below hulls and wings. To a great extent, the majority of these can be termed ground effect, or water effect vehicles rather than hovercraft. The principal difference is that a hovercraft can lift itself while still, whereas the majority of other designs require forward motion to create lift. These active motion surface effect vehicles are known in specific cases as echinoplane and hydrofoils. The first mention in the historical record of the concepts behind surface effect vehicles that use the term hovering was by Swedish scientist Emanuel Swedenborg in 1716. In 1915 Austrian Dagobert Mar 1/4 Layer built the world's first water effect vehicle. Shaped like a section of a large aerofoil, the craft was propelled by 4 aero engines driving 2 submerged marine propellers, with a 5th engine that blew air under the front of the craft to increase the air pressure under it. Only when in motion could the craft trap air under the front, increasing lift. The vessel also required a depth of water to operate and could not transition to land or other surfaces. Designed as a fast torpedo boat, the Wasserschleit boot had a top speed over 32 knots. It was thoroughly tested and even armed with torpedoes and machine guns for operation in the Adriatic. It never saw actual combat, however, and as the war progressed it was eventually scrapped due to lack of interest and perceived need, and its engines returned to the Air Force. The theoretical grounds for motion over an air layer were constructed by Konstantin Eduardovich Tchaikovsky in 1926 and 1927. In 1929, Andrew Kucher of Ford began experimenting with the lever pad concept, metal discs with pressurized air blown through a hole in the center. Lever pads do not offer stability on their own, several must be used together to support a load above them. Lacking a skirt, the pads had to remain very close to the running surface. He initially imagined these being used in place of casters and wheels in factories and warehouses where the concrete floors offered the smoothness required for operation. By the 1950s, Ford showed a number of toy models of cars using the system, but mainly proposed its use as a replacement for wheels on trains, with the lever pads running close to the surface of existing rails. In 1931, Finnish aero engineer Toivo J. Kaario began designing a developed version of a vessel using an air cushion and built a prototype in Talliaika Currency Jar Currency, in 1937. Kaario's design included the modern features of a lift engine blowing air into a flexible envelope for lift. Kaario never received funding to build his design, however. Kaario's efforts were followed closely in the Soviet Union by Vladimir Lvov, who returned to the solid-sided design of the Wasserschleit boot. Lvov designed and built a number of similar craft during the 1930s, and his L-5 fast attack boat reached 70 knots in testing. However, the start of World War II put an end to Lvov's development work. During World War II, an engineer in the United States of America, Charles Fletcher, invented a walled air cushion vehicle. Because the project was classified by the U.S. government, Fletcher could not file a patent. Christopher Cockerell, the idea of the modern hovercraft is most often associated with a British mechanical engineer Sir Christopher Cockerell. Cockerell's group was the first to develop the use of an annular ring of air for maintaining the cushion, the first to develop a successful skirt, and the first to demonstrate a practical vehicle in continued use. Cockerell came across the key concept in his design when studying the ring of airflow when high-pressure air was blown into the annular area between two concentric tin cans, one coffee and the other from cat food. This produced a ring of airflow, as expected, but he noticed an unexpected benefit as well. The sheet of fast-moving air presented a sort of physical barrier to the air on either side of it. This effect, which he called the momentum curtain, could be used to trap high-pressure air in the area inside the curtain, producing a high-pressure plenum that earlier examples had to build up with considerably more airflow. In theory, only a small amount of active airflow would be needed to create lift and much less than a design that relied only on the momentum of the air to provide lift, like a helicopter. In terms of power, a hovercraft would only need between 1/4 to half of the power required by a helicopter. Cockerell built several models of his hovercraft design in the early 1950s, featuring an engine mounted to blow from the front of the craft into a space below it, combining both lift and propulsion. He demonstrated the model flying over many Whitehall carpets in front of various government experts and ministers, and the design was subsequently put on the secret list. In spite of tireless efforts to arrange funding, no branch of the military was interested. As he later joked, the Navy said it was a plane not a boat. The Air Force said it was a boat not a plane. And the Army was plain not interested. Senior N1. This lack of military interest meant that there was no reason to keep the concept secret, and it was declassified. Cockerell was finally able to convince the National Research Development Corporation to fund development of a full-scale model. In 1958 the NRDC placed a contract with Saunders-Roe for the development of what would become the Senior N1, short for Saunders-Roe, Nautical 1. The Senior N1 was powered by a 450 HP Alvis Lee in its engine powering a vertical fan in the middle of the craft. In addition to providing the lift air, a portion of the airflow was bled off into two channels on either side of the craft, which could be directed to provide thrust. In normal operation this extra airflow was directed rearward for forward thrust, and blew over two large vertical rudders that provided directional control. For low-speed maneuverability, the extra thrust could be directed fore or aft, differentially for rotation. Senior N1 made its first hover on June 11, 1959, and made its famed successful crossing of the English Channel on July 25, 1959. In December 1959, the Duke of Edinburgh visited Saunders-Roe at East Cowes and persuaded the chief test pilot, Commander Peter Lamb, to allow him to take over the Senior N1's controls. He flew Senior N1 so fast that he was asked to slow down a little. On examination of the craft afterwards, it was found that she had been dished in the bow due to excessive speed, damage which was never allowed to be repaired, and was from then on affectionately referred to as the Royal Dent. Skirts and other improvements. Testing quickly demonstrated that the idea of using a single engine to provide air for both the lift curtain and forward flight required too many trade-offs. A Blackburn-Mabora copyright for forward thrust and two large vertical rudders for directional control were added, producing the Senior N1 Mk2. A further upgrade with the Armstrong-Siddeley Viper produced the Mk3. Further modifications, especially the addition of pointed nose and stern areas, produced the Mk4. Although the Senior N1 was successful as a testbed, the design hovered too close to the surface to be practical. At 9 inches even small waves would hit the bow. The solution was offered by Cecil Latimer Needham, following a suggestion made by his business partner Arthur Audhume. In 1958 he suggested the use of two rings of rubber to produce a double-walled extension of the vents in the lower fuselage. When air was blown into the space between the sheets it exited the bottom of the skirt in the same way it formerly exited the bottom of the fuselage, recreating the same momentum curtain, but this time at some distance from the bottom of the craft. Latimer Needham and Cockerell devised a 4-feet-high skirt design which was fitted to the Senior N1 to produce the MKV, displaying hugely improved performance, with the ability to climb over obstacles almost as high as the skirt. In October 1961, Latimer Needham sold his skirt patents to Westland, who had recently taken over Saunders Roe's interest in the hovercraft. Experiments with the skirt design demonstrated a problem. It was originally expected that pressure applied to the outside of the skirt would bend it inward, and the now displaced airflow would cause it to pop back out. What actually happened is that the slight narrowing of the distance between the walls resulted in less airflow, which in turn led to more air loss under that section of the skirt. The fuselage above this area would drop due to the loss of lift at that point, and this led to further pressure on the skirt. After considerable experimentation, Dennis Bliss at Hovercraft Development Limited found the solution to this problem. Instead of using two separate rubber sheets to form the skirt, a single sheet of rubber was bent into a U-shape to provide both sides, with slots cut into the bottom of the U forming the annular vent. When deforming pressure was applied to the outside of this design, air pressure in the rest of the skirt forced the inner wall to move in as well, keeping the channel open. Although there was some deformation of the curtain, the airflow within the skirt was maintained and the lift remained relatively steady. Over time, this design evolved into individual extensions over the bottom of the slots in the skirt, known as fingers. Commercialization: through these improvements the hovercraft became an effective transport system for high-speed service on water and land, leading to widespread developments for military vehicles, search and rescue, and commercial operations. By 1962 many UK aviation and shipbuilding firms were working on hovercraft designs, including Saunders Roe Westland, Vickers Armstrong, William Denny, Britton Norman and Folland. Small-scale ferry service started as early as 1962 with the launch of the Vickers Armstrong VA3. With the introduction of the 254-passenger and 30-car carrying Senior N4 cross-channel ferry by Hoverloyd and Seaspeed in 1968, hovercraft had developed into useful commercial craft. Another major pioneering effort of the early hovercraft era was carried out by Jean Bertin's firm in France. Bertin was an advocate of the multi-skirt approach, which used a number of smaller cylindrical skirts instead of one large one in order to avoid the problems noted above. During the early 1960s he developed a series of prototype designs, which he called terraplanes if they were aimed for land use, and naviplanes for water. The best known of these designs was the N500 naviplane, built for Seaspeed by the Socia copyright tar copyright d'étude de dar copyright Vuelopement des or copyright Roglasseurs Marins. The N500 could carry 400 passengers, 55 cars and 5 buses. It set a speed record between Boulogne to Dover of 74 km. It was rejected by its operators who claimed it was unreliable. Another discovery was that the total amount of air needed to lift the craft was a function of the roughness of the surface it traveled over. On flat surfaces, like pavement, the needed air pressure was so low that hovercraft were able to compete in energy terms with conventional systems like steel wheels. However, as the hovercraft lift system acted as both a lift and very effective suspension, it naturally lent itself to high-speed use where conventional suspension systems were considered too complex. This led to a variety of hovertrain proposals during the 1960s, including England's tracked hovercraft and France's or copyright road train. In the US, Ruhr Incorporated and Garrett both took out licenses to develop local versions of the or copyright road train. These designs competed with maglev systems in the high-speed arena, where their primary advantage was the very low-tech tracks they needed. On the downside, the air blowing dirt and trash out from under the trains presented a unique problem in stations, and interest in them waned in the 1970s. By the early 1970s the basic concept had been well developed, and the hovercraft had found a number of niche roles where its combination of features were advantageous. Today they are found primarily in military use for amphibious operations, search and rescue vehicles in shallow water, and sporting vehicles. Design: hovercraft can be powered by one or more engines. Small craft, such as the Senior N6, usually have one engine with the drive split through a gearbox. On vehicles with several engines, one usually drives the fan, which is responsible for lifting the vehicle by forcing high-pressure air under the craft. The air inflates the skirt under the vehicle, causing it to rise above the surface. Additional engines provide thrust in order to propel the craft. Some hovercraft use ducting to allow one engine to perform both tasks by directing some of the air to the skirt, the rest of the air passing out of the back to push the craft forward. Uses: commercial. The British aircraft and marine engineering company Saunders Roe built the first practical man-carrying hovercraft for the National Research Development Corporation, the Senior N1, which carried out several test programs in 1959 to 1961, including a cross-channel test run in July 1959 piloted by Peter Lamb, an ex-naval test pilot and the chief test pilot at Saunders Roe. Christopher Cockerell was on board, and the flight took place on the 50th anniversary of Louis Blanc copyright riot's first aerial crossing. The Senior N1 was powered by a single-piston engine, driven by expelled air. Demonstrated at the Farnborough Air Show in 1960, it was shown that this simple craft could carry a load of up to 12 Marines with their equipment as well as the pilot and co-pilot with only a slight reduction in hover height proportional to the load carried. The Senior N1 did not have any skirt, using instead the peripheral air principle that Sir Christopher had patented. It was later found that the craft's hover height was improved by the addition of a skirt of flexible fabric or rubber around the hovering surface to contain the air. The skirt was an independent invention made by a Royal Navy officer, C.H. Latimer Needham, who sold his idea to Westland, and who worked with Sir Christopher to develop the idea further. The first passenger-carrying hovercraft to enter service was the Vickers VA-3, which in the summer of 1962 carried passengers regularly along the North Wales coast from Moreton, Merseyside, to Rhyl. It was powered by two turboprop aero engines and driven by propellers. During the 1960s Saunders Roe developed several larger designs which could carry passengers, including the Senior N2, which operated across the Solent in 1962 and later the Senior N6, which operated across the Solent from Southsea to Ryde on the Isle of Wight for many years. In 1963 the Senior N2 was used on an experimental service between Weston-super-Mare and Penarth under the aegis of P. and de Campbell, the paddle steamer operators. Operations by Hover Travel commenced on July 24, 1965. Using the Senior N6 which carried just 38 passengers. Two 98-seat April 1, 88 hovercraft were introduced on this route in 1983, and in 2007 these were joined by the first 130-seater BHT-130 craft. The April 1, 88 and the BHT-130 were notable as they were largely built by Hoverwork using shipbuilding techniques materials rather than the aircraft techniques used to build the earlier craft built by Saunders Roe British Hovercraft Corporation. Over 20 million passengers had used the service as of 2004. The service is still operating and is by far the longest, continuously operated hovercraft service. In 1966, two cross-channel passenger hovercraft services were inaugurated using Senior N6 hovercraft. Hoverloid ran services from Ramsgate Harbour, England, to Calais, France, and Townsend Ferries also started a service to Calais from Dover, which was soon superseded by that of Seaspeed. As well as Saunders Roe and Vickers, other commercial craft were developed during the 1960s in the UK by Cushion's Craft and Hover Marine based at Woolston. One of these models, the HM2, was used by Red Funnel between Southampton and Cowes. The world's first car-carrying hovercraft was made in 1968, the BHC Mountbatten class models, each powered by four Bristol Proteus turboshaft engines. These were both used by rival operators Hoverloid and Seaspeed to operate regular car and passenger carrying services across the English Channel. Hoverloid operated from Ramsgate, where a special hoverport had been built at Pegwell Bay, to Calais. Seaspeed operated from Dover, England, to Calais and Boulogne in France. The first Senior N4 had a capacity of 254 passengers and 30 cars, and a top speed of 83 km. The channel crossing took around 30 minutes and was run rather like an airline with flight numbers. The later Senior N4MKE had a capacity of 418 passengers and 60 cars to the Isle of Wight. These were later joined by the French-built SEDAM N500 Navyplane with a capacity of 385 passengers and 45 cars. Only one entered service and was used intermittently for a few years on the cross-channel service until return to SNCF in 1983. The service ceased in 2000 after 32 years, due to competition with traditional ferries, catamaran, the disappearance of duty-free shopping within the EU and the advancing age of the Senior N4 hovercraft and the opening of the Channel Tunnel. The commercial success of hovercraft suffered from rapid rises in fuel prices during the late 1960s and 1970s, following conflict in the Middle East. Alternative overwater vehicles such as wave-piercing catamarans use less fuel and can perform most of the hovercraft's marine tasks. Although developed elsewhere in the world for both civil and military purposes, except for the Solent ride to South Sea crossing, hovercraft disappeared from the coastline of Britain until a range of Griffon hovercraft were bought by the Royal National Lifeboat Institution. Civilian non-commercial, in Finland, small hovercrafts are widely used in maritime rescue and during the Rasputitsa as archipelago liaison vehicles. In England, hovercraft of the Burnham-on-Sea area rescue boat are used to rescue people from thick mud in Bridgewater Bay. Avon Fire and Rescue Service became the first local authority fire service in the UK to operate a hovercraft. It is used to rescue people from thick mud in the Weston-super-Mare area and during times of inland flooding. A Griffon rescue hovercraft has been in use for a number of years with the Airport Fire Service at Dundee Airport in Scotland. It is used in the event of an aircraft ditching in the Tay estuary. Numerous fire departments around the US/Canadian Great Lakes operate hovercraft for water and ice rescues, often of ice fishermen stranded when ice breaks off from shore. In October 2008 the Red Cross commenced a flood rescue service hovercraft based in Inverness, Scotland. Gloucestershire Fire and Rescue Service received 2 flood rescue hovercraft donated by Severn Trent Water following the 2007 UK floods. Since 2006 hovercraft have been used in aid in Madagascar by HoverAid, an international NGO who use the hovercraft to reach the most remote places on the island. The Scandinavian airline SAS used to charter an April 1, 1988 hovercraft for regular passengers between Copenhagen Airport, Denmark, and the SAS hovercraft terminal in Malmö Paragraph, Sweden. In 1998, the U.S. Postal Service began using the British-built Hoverwork April 1, 1988 to haul mail, freight, and passengers from Bethel, Alaska, to and from 8 small villages along the Kuskokwim River. Bethel is far removed from the Alaska road system, thus making the hovercraft an attractive alternative to the air-based delivery methods used prior to introduction of the hovercraft service. Hovercraft service is suspended for several weeks each year while the river is beginning to freeze to minimize damage to the river ice surface. The hovercraft is able to operate during the freeze-up period. However, this could potentially break the ice and create hazards for villagers using their snowmobiles along the river during the early winter. In 2006, Kvikak Marine Industries of Seattle, USA built, under license, a cargo passenger version of the Hoverwork BHT-130. Designated Suna X, it is used as a high-speed ferry for up to 47 passengers and 47,500 pounds of freight serving the remote Alaskan villages of King Cove and Cold Bay. An experimental service was operated in Scotland across the Firth of Forth, from 16 to July 28, 2007. Marketed as Forthfirst, the service used a craft chartered from Hover Travel and achieved an 85% passenger load factor. As of 2009 the possibility of establishing a permanent service is still under consideration. Since the Channel routes abandoned hovercraft, and pending any reintroduction on the Scottish route, the United Kingdom's only public hovercraft services that operated by Hover travel between South Sea and Ryde on the Isle of Wight. From the 1960s, several commercial lines were operated in Japan, without much success. In Japan the last commercial line had linked Oeita Airport and Central Oeita but was shut down in October 2009. Hovercraft are still manufactured in the UK near to where they were first conceived and tested in the Isle of Wight. They can also be chartered for a wide variety of uses including inspections of shallow-bed offshore wind farms and VIP or passenger use. A typical vessel would be a Tiger IV or a Griffon. They are light, fast, road transportable and very adaptable with the unique feature of minimizing damage to environments. Military. First applications of the hovercraft in military use was with the Senior N1 through Senior N6 craft built by Saunders Roe in the Isle of Wight in the UK and used by the UK Joint Forces. To test the use of the hovercraft in military applications, the UK set up the Inter-Service Hovercraft Trials Unit base at Lee on the Solent. This unit carried out trials on the Senior N1 from Mk1 through Mk5 as well as testing the Senior N2, Senior N3, Senior N5 and Senior N6 craft. Currently the Royal Marines use the Griffon Hoverwork 2400 TD hovercraft, the replacement for the Griffon 2000 TDX Class ACV as a tactical craft. The 2000 was deployed by the UK in Iraq. In the US, during the 1960s, Bell licensed and sold the Saunders Roe Senior N5 as the Bell SK5. They were deployed on trial to the Vietnam War by the United States Navy as PACV patrol craft in the Mekong Delta where their mobility and speed was unique. This was used in both the UK Senior N5 curved deck configuration and later with modified flat deck, gun turret and grenade launcher designated the 9255 PACV. The United States Army also experimented with the use of Senior N5 hovercraft in Vietnam. 3 hovercraft with a flat deck configuration were deployed to Dong Tam in the Mekong Delta region and later to Ben Luc. They saw action primarily in the Plain of Reeds. One was destroyed in early 1970 and another in August of that same year, after which the unit was disbanded. The only remaining U.S. Army Senior N5 hovercraft is currently on display in the Army Transport Museum in Virginia. Experience led to the proposed Bell SK-10, which was the basis for the LCAC-class air-cushioned landing craft now deployed by the U.S. and Japanese Navy. The Soviet Union was the world's largest developer of military hovercraft. Their designs range from the small Zilum-class ACV, comparable to the Senior N6, to the monstrous ZUBR-class LCAC, the world's largest hovercraft. The Soviet Union was also one of the first nations to use a hovercraft, the Bora, as a guided missile corvette, though this craft possessed rigid, non-inflatable sides. With the fall of the Soviet Union, most Soviet military hovercraft fell into disuse and disrepair. Only recently has the modern Russian Navy begun building new classes of military hovercraft. The Iranian Navy operates multiple British-made and some Iranian-produced hovercrafts. The Tonda or Thunderbolt comes in varieties designed for combat and transportation. Iran has equipped the Tonda with mid-range missiles, machine guns and retrievable reconnaissance drones. Currently they are used for water patrols and combat against drug smugglers. The Finnish Navy designed an experimental missile attack hovercraft class, Tuuli-class hovercraft, in the late 1990s. The prototype of the class, Tuuli, was commissioned in 2000. It proved an extremely successful design for a literal fast attack craft, but due to fiscal reasons and doctrinal change in the Navy, the hovercraft was soon withdrawn. The People's Army Navy of China operates the Jingzhou class LCAC. This troop and equipment carrying hovercraft is roughly the Chinese equivalent of the U.S. Navy LCAC. Recreational sport, small commercially manufactured, kit or plan-built hovercraft are increasingly being used for recreational purposes such as inland racing and cruising on inland lakes and rivers, marshy areas, estuaries and inshore coastal waters. The Hovercraft Cruising Club supports the use of hovercraft for cruising in coastal and inland waterways, lakes and locks. The Hovercraft Club of Great Britain, founded in 1966, regularly organises inland and coastal hovercraft race events at various venues across the United Kingdom. In August 2010, the Hovercraft Club of Great Britain hosted the World Hovercraft Championships at Towcester Racecourse. The World Hovercraft Championships are run under the auspices of the World Hovercraft Federation. Similar events are also held in Europe and the US. Other uses: Hoverbarge, a real benefit of air cushion vehicles in moving heavy loads over difficult terrain, such as swamps, was overlooked by the excitement of the British government funding to develop high-speed hovercraft. It was not until the early 1970s that the technology was used for moving a modular marine barge with a dragline on board for use over soft reclaimed land. Mackay's, now known as Hovertrans, produced a number of successful hoverbarges, such as the 250-ton payload OEC Pearl which operated in Abu Dhabi, and the twin 160-ton payload Yukon Princesses, which ferried trucks across the Yukon River to aid the pipeline build. Hoverbarges are still in operation today. In 2006, Hovertrans launched a 330-ton payload drilling barge in the swamps of Suriname. The hoverbarge technology is somewhat different from high-speed hovercraft, which has traditionally been constructed using aircraft technology. The initial concept of the air cushion barge has always been to provide a low-tech amphibious solution for accessing construction sites using typical equipment found in this area, such as diesel engines, ventilating fans, winches and marine equipment. The load to move a 200-ton payload ACV barge at 5 kN would only be 5 tons. The skirt and air distribution design on the high-speed craft again is more complex, as they have to cope with the air cushion being washed out by a wave and wave impact. The slow speed and large monochamber of the hover barge actually helps reduce the effect of wave action, giving a very smooth ride. The low pull force enabled a helicopter to pull a hover barge across snow, ice and water in 1982. Hover trains. Several attempts have been made to adopt air cushion technology for use in fixed-track systems, in order to utilize the lower frictional forces for delivering high speeds. The most advanced example of this was the Your Copyright Row train, an experimental high-speed hover train built and operated in France between 1965 and 1977. The project was abandoned in 1977 due to lack of funding, the death of its lead engineer and the adoption of TGV by the French government as its high-speed ground transport solution. A test track for a tracked hovercraft system was built at Yarmouth near Cambridge, England. It ran southwest from Sutton Galt, sandwiched between the Old Bedford River and the smaller counter drain to the west. Careful examination of the site will still reveal traces of the concrete piers used to support the structure. The actual vehicle, RTV-31, is preserved at Rail World in Peterborough and can be seen from trains, just southwest of Peterborough railway station. The vehicle achieved 104 mph on February 7, 1973, but the project was cancelled a week later. The project was managed by Tracked Hovercraft Limited, with Dennis Bliss as director in the early 1970s, only to be axed by the Aerospace Minister, Michael Heseltine. Records of this project are available from the correspondence and papers of Sir Harry Legge Bourke, MP at Leeds University Library. Heseltine was accused by Ray Neve and others of misleading the House of Commons when he stated that the government was still considering giving financial support to the hover train, when the decision to pull the plug had already been taken by the Cabinet. Despite promising early results, the Cambridge project was abandoned in 1973 due to financial constraints, but parts of the project were picked up by the engineering firm Alfred McAlpine, only to be finally abandoned in the mid-1980s. The Tracked Hovercraft project and Professor Laithwaite's maglev train system were contemporaneous, and there was intense competition between the two prospective British systems for funding and credibility. At the other end of the speed spectrum, the Dorf-Bahn Force has been in continuous operation since 1985. This is an unusual underground air cushion funicular rapid transit system, situated in the Austrian ski resort of Safors. Only 1,280 am long, the line reaches a maximum speed of 25 mph. A similar system also exists in Narita International Airport near Tokyo, Japan. In the late 1960s and early 1970s, the U.S. Department of Transport's Urban Mass Transit Administration funded several hover train projects which were known as Tracked Air Cushion Vehicles or TACVs. They were also known as Aerotrains since one of the builders had a license from Bertin's Aerotrain Company. 3 separate projects were funded. Research and development was carried out by RU, Incorporated, Garrett I Research and Grumman. The UMTA built an extensive test site in Pueblo, Colorado, with different types of tracks for the different technologies used by the prototype contractors. They managed to build prototypes and do a few test runs before the funding was cut. Non-transportation. The Hoover Constellation was a spherical canister-type vacuum cleaner notable for its lack of wheels. Floating on a cushion of air, it was a domestic hovercraft. They were not especially good as vacuum cleaners as the air escaping from under the cushion blew on collected dust in all directions, nor as hovercraft as their lack of a skirt meant that they only hovered effectively over a smooth surface. Despite this, original Constellations are sought-after collectibles today. The Flymo is an air cushion lawn mower which uses a fan on the cutter blade to provide lift. This allows it to be moved in any direction, and provides double duty as a mulcher. The Marylebone Cricket Club owns a hover cover that it uses regularly to cover the pitch at Lord's Cricket Ground. This device is easy and quick to move, and has no pressure points, making damage to the pitch less likely. The system is quite popular at major pitches in the UK. Preservation. Lyon-on-Solent, Hampshire, England, is the home to the Hovercraft Museum, which houses the world's largest collection of hovercraft designs, including some of the earliest and largest. Much of the collection is housed within two retired Senior N4 hovercraft, and many hovercraft in the collection are operational. Hovercraft are still in use between Ryde on the Isle of Wight and Southsea on the mainland. The service, operated by Hover Travel, runs many times an hour and is the fastest way of getting on or off the island. Large passenger hovercraft are still manufactured on the Isle of Wight. Records. World's largest civil hovercraft, the BHC Senior N4 MKA, at 56.4 am length and 310 metric tons weight, can accommodate 418 passengers and 60 cars. World's largest military hovercraft, the Russian ZUBR class LCAC at 57.6 meters length and a maximum displacement of 535 tons. This hovercraft can transport 3 T-80 main battle tanks, 140 fully equipped troops, or up to 130 tons of cargo. 4 have been purchased by the Greek Navy. English Channel Crossing, 22 minutes by Princess Anne MCH Senior N4 MKA on September 14, 1995, World's Hovercraft Speed Record, September 18, 1995, Speed Trials, Bob Wint 137.4 km per hour, 34.06 sex measured kilometer, longest continuous use. The original prototype Senior N6 MKI was in service for over 20 years, and logged a remarkable 22,000 hours of use. It is currently on display at the Hovercraft Museum in Lyon-on-Solent, Hampshire, England. See also, References, Notes. Bibliography, The Ruhr Aerotrain Tracked Air Cushion Vehicle. Shona Studios. Retrieved October 24, 2009. A web page on tracked air cushion vehicle research in the U.S., Volpe, John. Cumming, Streamliners Without Wheels. Popular Science, 51 article on tracked air cushion vehicle research in the U.S. External links, 1, Hovercraft at DMOZ, The Future of Hovercraft, the world's only dedicated hovercraft museum at Lyon-Solent, near Gosport, Portsmouth, UK. 1965 film of the Denny D2 hoverbus from the Scottish Screen Archive, National Library of Scotland, Hovercraft Resource, Royal Marines Super Hovercraft.